Now we're going to look at a mixed plan. And here we're going to define the mixed plan like this. So we want to set the regular time production at the smallest monthly demand rate. And then we want to use overtime and subcontracting to meet the demand. So that way there is no ending inventory beyond the safety stock. So it is like level production, except that it's also like chase production, because we are producing exactly what is demanded and we're making up the shortfall in capacity through overtime and subcontracting. So let's first look at what is the required production. So required production, remember from the previous problem, for the very first month you have to adjust for initial conditions. So 900 minus 25 minus 20 is 895. The rest of the months it's exactly the same as the demand. So that's the total amount we have to produce in each of these 6 months, and we want to produce at the rate of the minimum monthly demand rate. So let's see. From chase plan, which we did previously, we calculated the demand rate for each month, and you see that it is the minimum rate is 38 for the month of March. So from chase plan, the smallest demand rate is equal to 38 per day, okay, for the month of March. So now we're going to multiply 38 by the number of days. So 38 times 22 will give you 836, and 38 times 18 will give you 684. So there is a small amount of rounding in that 38. So we get 38 times 21 will give you 798. So it is the rounding, because of rounding, that there is a small amount of shortfall in the month of March. And then 38 times 21 is 798 again, and 38 times 22 is 836, and then 38 times 20 is 760. Now these are the production capacities. We have to compare these capacities against what is required for each of the months, and that will be our regular time actual production. So now production in regular time is we have to compare these two numbers, and you have to use the smaller one. So this is minimum, okay, between required production and production capacity. So here should be, you compare this and that. So you have a need to produce 895, but you can only produce 836. That's the capacity. So 836 is what you can produce. So here you need 700. The production capacity is 684. Now 800 is the required production. You can only produce 798. So here again 798, 836, and 760. So if the production capacity is more than the required production, then the required production is what you will produce. You will not produce more than what you need. Next, let's compute the shortage. Now, shortage is simply required production minus actual production. So, required production minus production in regular time. That's your actual production. So here we have 895 minus 836 will give you 59. 700 minus 684 will give you 16. 800 minus 798 is 2. 1200 minus 798 is 402. Then 1500 minus 836 is 664. 1100 minus 760 is 340. So these are the shortages. We have to make these shortages up using overtime first and then subcontract. Next is overtime capacity. So we have to first determine what is our overtime capacity, and then we need to determine how much of this 59 can be made up using overtime capacity. So remember, from the first page, we know that the overtime capacity is limited to 25% of regular time production. So whatever the regular time production capacity is, okay, 25% of that is the maximum that we can schedule as overtime capacity. And we'll round this a little bit. So round down, because capacity should be rounded down. So this is 25% of production capacity. So this will be 25% of 836. Okay, so that will give you 209, or 0.25 times 684 is 171, and then 0.25 times 798 is, rounding it down, 199. So same 199 here also. So 0.25 times 836 is 209, and 760 is 190. Now production in overtime is the smaller of these two. So let me write that down here. Production in OT is minimum of shortage and overtime capacity. So that's what we have to do here.